Hello, in this lecture we will see the classification of signals. Okay, so though the signal can be classified into many classes, but we will see few of them as important for this course only. Okay, first signal can be classified into the as continuous time signals and discrete time signals. Okay, as a continuous time and discrete time signal. Second, we can classify as analog and digital signals. The third type may be periodic and aperiodic signals. And fourth one is energy and power signals. And the last one is the deterministic and random signals. Okay, so we will cover these 5 categories in this lecture. Okay, so first let us see what is a continuous time and discrete time signal. So continuous time and discrete time. Now this classification is based on the time axis. Is based on the time axis. Okay. For example, this signal. Okay. So this is time axis t, and let us call the signal as x of t. So the continuous time means this signal is defined at every value of this time axis. Okay, so you take any time and the signal is defined on that point. Okay, so this is known as a continuous time signal. Okay, means this is defined in every instant of time. Okay, so this is important. Okay, now next, if the signal is defined only on say fixed instance of time. Okay, for example, consider this signal. Okay, so this signal say x of n, and it is defined only on the fixed time instance. Okay, and means it is defined only on these integer values only. So this is 0, 1, 2, 3, 4, minus 1, minus 2, and so on. Okay, and between this 0 and 1 there is this signal doesn't exist. Okay, so this signal is defined only on the integer values of this axis. Okay, so this is known as a discrete time signal, and this is a continuous time signal. Okay, so now remember that this classification is based on this x-axis or time axis. Okay, and now let us move to the second classification, which is analog and digital. This classification is based on the y-axis, or you can say the amplitude axis. Okay, so when you are required to classify the signal as analog or digital, you need to consider this y-axis or the amplitude axis. Okay, so for example, consider this signal. This is t, this is x of t, and as we can see that this signal can opt any value on the y-axis. Okay, so you take any point on y-axis and there is a possibility that the signal can take that value. Okay, means there is no restriction on the values which can this signal opt. Okay, so this signal can take any value, so this is known as analog signal. Okay, now then the digital signal is one in which the signal can take only the specific values on this y-axis. Okay, for example, consider this signal. Okay, so in this signal is it can take only fixed values. It can take say -1 or 0 or 1 or 2 or 3 and so on. So the y-axis is fixed. Okay, means the signal cannot opt any arbitrary value. It can take on values only from this set. Okay, some specified set. Okay, now if the signal can take m values, then it is known as an m-ary signal. Okay, and the binary signal which is used in computers is the special case of this signal. When this m is equal to 2, then this is known as a binary signal. Okay, so this type of signals are known as digital signal, and this binary signal means it can take only two values, for example 0 or 1. Okay, so this is a binary signal. Now there is some confusion among students about the between the analog and continuous time and the digital and the discrete time signal. So let us clarify it. So note that the analog signal is not necessarily a continuous time. Okay, an analog signal could be also discrete time, and the digital signal is not necessarily a discrete time. Okay, means this digital signal could be continuous time also. Okay, so this this is the more general classification. You can say that a signal could be analog and continuous time, digital and continuous time, analog and discrete time, and digital and discrete time. Okay, so generally when we talk about analog and digital, so we generally do not specify the time axis. Okay, what is its nature in time. Okay, and so let us give example of these signals. Okay, so consider following signals. Okay, so here I have plotted four types of signals. Okay, and look at this signal. So let me call this is signal A, this is B, this is C, this is D. Okay, so look at this signal. This is defined on every instant of time. Okay, so this is continuous time, and also it can opt any value on the y-axis. So this qualifies both the conditions of being analog and continuous time. So basically this signal is an analog and continuous time. Okay, so this is analog and continuous time signal. Okay, now look at this signal. So this signal is also defined on every instant of time. Okay, so you take any instant and you will get a value of this signal, or for example this time, and there is a value of this signal. So clearly this signal is a continuous time signal. But when you look at this vertical axis or the amplitude axis, you can see that this signal can have only two values. Either say this is 2 or and this is -1. Okay, so this can take only two values. So this is this digital signal. Okay, so this is digital and continuous time. And look at this third signal. So this is defined only on fixed time instance. Okay, so this is defined here, here and here. Okay, and say between at this point, if you consider this point, so there is no value of this signal. Okay, so means this is a discrete time signal. Okay, so there is a discretization of the time axis. So this is discrete time, but when you look at the vertical axis, we can see that this signal is free of any value. Okay, means this signal is analog in nature. So this is the example of an analog and discrete time. Okay, and this last case, in this last case, the time axis is discretized, means it is defined only at fixed instants of time. So this is a discrete signal. And look at this vertical axis, since it can have only two possible values, 2 and 1, and so this is a digital signal. Okay, so this is digital and discrete time. Okay, so this is a digital and discrete time signal. Okay, okay, so this is the way when you have to look at the signals when you are asked for analog and digital and continuous time and discrete time. Okay, so clearly when you need to choose between analog and digital, you have to look at this vertical axis and you need to check whether it is free to choose of any value or whether it is taking only fixed values. Okay, so this is the analog and digital case. Okay, and to look for continuous time and discrete time, you need to look at this x-axis or time axis, and if the signal is defined at every instance of time, then if it is defined at every instant of time, as in this case A and B, so that will be a continuous time signal. Okay, and when it is defined only for fixed values of time, then it is a discrete time signal. Okay, so now let us move to the third type. Okay, so the third classification is periodic and aperiodic signals. Okay, so a signal is said to be periodic if it satisfies this condition. Okay, so if the signal satisfies this condition x of t plus t naught equal to x of t, then this signal is a periodic signal. Okay, otherwise it is an aperiodic signal. So it means the signal repeats itself after the t naught set time t naught. Okay, so and this t naught, the minimum t naught for which the signal repeats itself, is known as the fundamental time period of the signal. Okay, it means the signal will repeat itself for t naught also, or 2t naught, or 3t naught, and so on. Okay, but this minimum time for which it repeats itself is known as the fundamental time period. For example, consider this signal, and you can see that this signal is repeating itself after the fixed value of time. For example, what is the value at this point -1? The same value, this part of signal will get repeated after this time. Okay. So between -1 and 1, the same thing is happening between 1 and 3 also. Okay. So it is repeating itself after 2 seconds. So its fundamental time period is 2 seconds. Okay. And this is a periodic signal. And if we shift this signal by +2 by 2 seconds in the right side or left side, the signal will not change. Okay. So we can say that the periodic signals are starts at -infinity and they go up to +infinity, means the periodic signals are everlasting. Periodic signals are everlasting signals. Okay, means they are defined from -infinity time, -infinity to +infinity. Okay, they are defined for every time. Okay, and the aperiodic signal means if there is no fixed pattern in the signal. Okay, means we cannot find such a time t naught for which the signal repeats itself. Okay, and such signals are known as aperiodic signals. Okay, and they need not be defined for every time period, means from -infinity to +infinity. Okay, they could be a pulse also. Okay, so this is also a periodic signal, okay, which is defined only between 0 and now. The next classification, the fourth one, is the energy signal and power signal. Okay, so a signal is an energy signal if its energy is finite. If this energy is finite, or means for any signal x of t, if its energy E of x is finite, then it is an energy signal. And we know that the formula for energy is integration from minus to plus infinity x square t dt. Okay, and if the E of x is infinity, then the signal is not an energy signal. Okay, then a power signal, a signal is power signal if its power P of x is finite. Okay, so we know from the definition that power is limit t tends to infinity 1 over t integration from minus t by 2 to plus t by 2 x square t dt. So we can say that this part is an energy of the signal and we are averaging it over the infinite time period where t tends to infinity. Okay, so clearly for the power to be finite, the energy will be infinite. Okay, so for power signals, the energy is infinity. Okay, so if for a signal energy is infinite and power is finite, then the signal is a power signal. Okay, and if both energy and power are infinite, then then the signal is neither energy nor power. Okay, so a signal could be an energy signal, a power signal, or it could be neither energy nor power. So for an energy signal is finite, and what will be the power of the energy signal? So we can check that the power will be 0. Okay, for an energy signal the power is 0, because if the energy is finite, then its average taken over the infinite time period will be 0. And for power signal, the energy will be infinite and power will be finite. And for signal, which is neither energy nor power, its energy is infinite and its power is also infinite. Okay, and for a finite duration signal, for example, if any signal is of finite duration, okay, if it is from 0 to t, say in amplitude a, so this type of signals which are defined only for finite duration, they are always energy signals. Okay, and a signal, if its amplitude is decaying with time, for example, this kind of signals for which amplitude is tends to 0 as t tends to infinity. This type of signals are also energy signals. Okay, and if the signal which is defined for infinite time, okay, and so for example, sinusoidal signals which are everlasting and they are periodic. Okay, so periodic signals or power signals. Periodic signals are always power signals. Okay, and for signals which are neither periodic nor defined for finite time, and if their amplitude is increasing with time, okay, for example, this REM signal r of t, whose amplitude is increasing with time, so its amplitude is approaching infinity as t tends to infinity. So for this type of signals, both energy and power are infinite, so this signal is neither energy nor power. Okay, so these are few comments by which you can classify the signal whether it is energy or power just by looking at its shape. Okay, now remember that the unit step signal u of t, which is 1 after t equal to 0 and 0 before t equal to 0. So this is a power signal. Okay, because its amplitude is not approaching infinity, it is fixed with time. Okay, so this is an example of a power signal. Okay, now the last classification is the deterministic and random signal. So a deterministic signal is one for which a clear mathematical or graphical description is available. Okay, so this type of signals is known as deterministic signal. Okay, a signal for which the clear mathematical or graphical description is available is known as a deterministic signal. Okay, so for example, x of t equal to a sine 2 pi t. Okay, so if you are given f and t and a, you can clearly find out the what is x of t. Okay, so this is a mathematical description for the sinusoid. Okay, and so we can calculate the value of the signal at any time instant provided a and f. So this is an example of a deterministic signal. And or for example, if you have some graphical description, for example, this is a pulse which is defined for -1 to +1 as an amplitude a. So this is also deterministic signal. Okay, for example, this means that you can find out the any value at any time instant. Okay, value of this signal at any time instant. For example, you consider this time and we know that the value at this point is 0, or if you take the time as half 1 by 2, then its value is a. Okay, a could be say 1 or 2. Okay, so this is a deterministic signal. Also, this is also deterministic signal. Okay, now as opposed to these signals, for example, a random signal is one for which you do not have any mathematical description or a graphical description. Okay, clear graphical description. For example, if you record and plot our speech signal. Okay, so this will be something, so it could be like this. Okay, and this is there is no certain pattern and there is no equation, mathematical equation available for this signal, and so you cannot find the exact value of this signal at any time t. Means based on this information you cannot predict the information for any arbitrary time t. Okay, so this type of signals are known as random signals, and their analysis requires special techniques based on the probabilistic models are required to analyze this type of signals. Okay, so in this video we have seen the classification of signals. The first one is continuous time and discrete time, and we have seen that this classification is based on the x-axis or time axis. Okay, and second one is analog and digital, which is based on the vertical axis or amplitude axis. Okay, and the third one is periodic and aperiodic. So a signal is periodic if it repeats after itself after a certain time, then it is a periodic signal, and if there is no certain patterns in the signal, then the signal is an aperiodic signal. And the fourth one is energy and power signal. So if the signal's energy is finite, we call it an energy signal, and if the power is finite, then we call it a power signal. Okay, and the signal may not belong to these two categories, may be neither energy nor power. Okay, if both energy and power are infinite. And the last one is deterministic and random signal. So deterministic signals are those for which mathematical or graphical representation is available, then it is a deterministic signal, and if not so, then the signal is a random signal. Okay, for which we don't have any mathematical equation so that we can find any value of the signal at given time instant. Okay, and treatment of these signals requires special techniques with probabilistic techniques. Okay, thank you.